Hello, great 10 Mindsetters, and welcome to it. This is your show, Learn Extra Live, with me, Abraham, and of course, Tamilin. How are you doing?
I'm very well, thanks. How are you?
I'm superb. I'm
Good.
supercharged. It's a Monday.
Good. It is. Maths Monday. Awesome.
But what's on the menu today?
Today we're carrying on. It's a bit of a continuation from last week. We did functions last week.
Yes.
We introduced quite a lot of new notation and the ways in which we draw graphs from the different functions. And today we're kind of just going to build on that a bit more.
Awesome. I'm so looking forward.
Yep.
I hope the great 10s are also looking forward as I do.
I'm sure they must be. This is always a really important section. And as I actually said last week, even if you're in grade 11 or 12, it's worth listening because it's just going back to the roots of the section, and anything that you maybe weren't sure of, you could maybe clarify today.
Well, never take anything for granted. It is always worth it. Thank you very much, Tamilin, and go take your position. Right, Mindsetters, let me tell you about these exciting news before we begin our show. One, are you the next Future Star? We've been telling you about the Future Stars competition, and now this is your chance to learn more and know more about it. The Future Stars competition inspires the youth in believing in themselves and the power that education has in achieving their dreams. Now, for you to enter, simply log on to sastudy.co.za and tell us why are you the next Future Stars, and also you can share how do you dream it, believe it, and do it. Lastly, the competition is open in South Africa only and to young people that are between the ages of 16 and 21. There are great prizes to be won. Trust me, there's about 10 grand worth of prizes to be won by 5 lucky Mindsetters. So make sure that you log on to sastudy.co.za. But other than that, to chat with me on the show and to learn more with Tamilin, simply log on to Facebook. Our Facebook link is facebook.com/learn extra. You can also go over Twitter and follow me, Tim Follow Back. We are on @learn extra. Also, for the notes, they're for free. You can download them off our website, which is learnextra.co.za. To all that Mindsetters that are tuning in from Fumana Comprehensive School, the school that we visited on Friday, holla to you and let's learn more. Tamilin, take your time.
Thanks, Avram. Right, guys, welcome, and let's get going with some functions. All right, last week, as I mentioned, we introduced functions. We spoke about the concept of having x values, and we substitute them into an equation, and out comes y values. And those x and y values together form coordinate points, okay? And together, when we plot these coordinate points, according to the, I'm sure if you watched last week, you'll remember the word, the relational rule that we had. That determines the type of graph that we'll end up getting when we plot our x and our y coordinates, okay? So as a quick recap, we had a look at the straight line function or the linear function last week. And when we had the straight line equation, when we plotted values of x and y, out came a straight line graph, okay? Today, we're going to be having a look at parabolas, which is another, it's quadratic functions that we're working with, as well as exponential functions. Right, let's have a quick look at our lesson description. Okay, so today we're going to be having a look at the standard equation of a parabola and an exponential graph. Remember, every function, guys, has got its own unique standard equation, and that is what determines the type of graph that you are going to be working with. Okay, so it's really important that we become extremely familiar with the standard equation of each one of your functions. All right, once we've had a look at that, we're going to investigate the influence of the a value and the q value and what they actually do to each of the functions. You will find that in your linear function, your quadratic function, your hyperbolic, and your exponential function, so in all of your graphs, you get the standard a and q value, and they all play a very special role in terms of what the graph looks like. So it's really important that you become very familiar, guys, with what those values do to each of your functions, okay? Okie dokes. Now then we're going to be having a look at how to sketch your graphs. Okay, that's always an important one. They'll give us the equation, and we actually have to sketch the graph and actually draw it. So that's important, plotting it on the Cartesian plane. And finally, the last thing we're going to learn to do is the reverse of that, all right? If the graph has been given to us, so we've been given the picture, and what we have to do is actually find the equation from that. And that is a very important skill to learn as well, guys, because that often comes up in tests and exams. Right, so let's get going with some key concepts, okay? Just to quickly run through them, and then each of these concepts we will go over in detail. So let's just give it an overview. Right, the standard equation of a parabola, okay, then as we go along, you'll see we work with this a lot, is going to be y equals ax squared plus q. Okay, there's that a and that q value that I was talking about, and we'll determine in a minute what those actually do to the parabola. Okay, in terms of just quickly just talking about it, the a determines the width of the parabola as well as if it's positive or negative. Very quickly, if I've got a positive parabola, it's going to look like so. A negative, let's just draw it underneath here, would look like so. And that would be determined by your a value, as well as how wide or how narrow that parabola actually is. So that a will help us determine all of that information over there. If we're finding the equation of a parabola, all right, we are going to go through an example of this, but I do suggest you jot down the equation, okay? If we're finding the equation of a parabola, that's if the graph has been given to us. This is going to be a really incredibly important formula for you to remember. Y is equal to a x minus x1 multiplied by x minus x2. And I'll teach you how we're going to apply that shortly. The exponential function, that is going to have the standard equation of y is equal to a times b to the power of x plus q, all right? A few restrictions, grade 10, that you need to be aware of with regards to this formula. Your b value has always got to be greater than 0. It cannot be negative, and it cannot be equal to 1. Okay, so those are just two restrictions to bear in mind regarding your b value. What does the a, the b, and the q actually do to an exponential graph? Well, the a is going to determine if your graph is positive or negative. Similar to a parabola, positive is going to be on the upper half of your x-axis, and your negative will look like so, obviously also depending on where your asymptote is. Okay. The b value in our equation determines the increasing or the decreasing nature of the graph, and the q represents your asymptote. Very quickly, guys, for those of you who are unsure as to what an asymptote is, okay? An asymptote is a value on your graph that if the graph were to actually touch that line, it would be undefined. It would actually not be valid, okay? So essentially the idea with an asymptote is that your function tends infinitely close to a particular asymptote, but it will never ever actually touch or meet that line, because at that line the function is undefined. Okay, so an asymptote is a line that your graph will never touch or will never cross. Okay, and that's what an asymptote is. Right, let's now get going and have a look at our quadratic functions. Okay. Right, quadratic functions, another word or the name we give to these functions is parabolas, okay? And really, to give it an image of what a parabola is, guys, it looks like a smiling or a frowning graph, okay? That's what we're looking, that's the shape of our parabola, okay? And once again, it depends on what that a value is as to whether our graph is going to be smiling or whether it is going to be frowning, okay? Right, as we mentioned earlier, the standard equation of our parabola is y equals ax squared plus q. And you guys are going to become very familiar with that. Right, what we're going to do is we're going to do a little bit of investigating. And we're going to take a few standard parabola quadratic functions, and we're going to plot the parabolas. And we're going to see what they look like, how they actually turn out, okay? So the first one we're having a look at is this one over here. Y equals x squared. What's the a value in this equation over here? If I were to look at it and try and establish what's the value of the a and what's the value of the q, do you guys agree with me that in fact we can't see an a value and neither can we see a q value, all right? So therefore, what are they, all right? The a value, remember, is whatever is in front of the x. So that's not a very straight line, but that's supposed to be a 1. Remember, it's if you've got an x, the coefficient of just x is always 1, okay? So the a value is a positive 1, all right? So let's just put that over here so we're taking notes of it. So the a value in this equation is a 1. And the q value, well, if I can't see it, I'm going to have to assume that it's 0. Okay, we're going to have nothing there. All right, so for my first equation, the a is 1 and the q is 0. Let's see what that looks like if we were to plot the graph. Now, from last week, remember, when we've got x values, we substitute them into our equation, out come y values, and together the x and the y form your coordinate pair. All right? Okay, so if I substituted -1 into my x squared y equals x squared equation, the first value that comes out is going to be, let's get rid of that. There we go. Is going to be +1. Okay, so my first coordinate point, the x is -1 and the y is now +1. All right? If we substituted 0 into my equation, okay, if I've got 0 squared, that's going to land up being just 0. So there's my next coordinate point, 0, 0. All right? And thirdly, if I were to substitute 1 into my equation, 1 times 1, or 1 squared, is obviously just 1. Okay, so here are my first set of coordinate points. So let's see, let's plot these and see what we've got here. My first coordinate point was x was -1 and y is +1. So there's my first dot. The next one, x was 0 and y was 0. And that's right bang in the middle over there. And just as a point, just as a note, what do we call that point where the x and the y axis meet each other? It is the origin. Okay, the origin where the coordinate points are 0, 0. And finally, I've got +1 and +1. That's going to be like so. Remember we said, grade 10s, that the a value over here is a +1. All right, now when we have got a parabola where the a is positive, your parabola is going to be smiling. Okay, so therefore, when I draw my line, it's going to go through my points, it passes through the origin, and it's going to go up like so, and it is smiling. Okay, and that is my first function. This one over here is my y equals x squared function. All right. Let's quickly have a look at what would happen if we had an y equals 2x squared. All right, so let's just quickly take a look at what the difference is over here. The a value, do we agree now, is 2? Okay, so that's the a value. So it's different to the first one. The first a value was only 1. And the q value, well, do you guys agree that in fact still it's 0? Okay, so we've got a 0 over here. The q value is still going to be 0. So therefore, if we were to substitute these three x values, -1, 0, and 1, into the equation of y is equal to 2x squared, let's see what we get. When we substituted -1 into the equation, 2 times by -1 squared, we get +2. When 0 gets substituted into the equation, we get the value of 0. And when 2 goes into the equation, we get a +2. And again, those form the coordinate points. So where x was -1, y is going to be +2. So there's my first coordinate point. Where x is 0, y is 0. There again, we're at the origin. And where x is 1, y is 2. So therefore, when I plot my graph, the only difference, it still passes through the origin. The only difference is that my graph is narrower. Okay, so there's something we need to notice about the equations. Both the a values were positive, so they were both smiling. Both the q values were 0, and they both passed through your origin. The only difference is that the a value in my first equation was a 1, and the a value in my second equation was a 2. And what we see in our second equation is that, in fact, if you notice, it's actually become narrower. All right. And so therefore, what we need to conclude about that is that the bigger your a value gets, the narrower your function, your parabola, will be. Okay. So let's finally, with this example, have a quick look at what would happen if my a value was a half. Okay, let's look at this equation. Let's use a different color. So this time, my value for a is -1/2. Okay, here there's two different things. First of all, the a is no longer positive, it's negative. And it's no longer a whole number, it's a fraction. So let's see what happens with that. And my q value, do you guys agree, is still 0. All right, so let's quickly plot, or let's sub in our points. If we subbed in 1, negative 1, we would land up with the value for y of negative a half. If we substituted in 0, we would still get the y value of 0. And if we substituted positive 1, we would get the value of positive a half. So let's plot. Right, where x was negative 1, y is now only, other way around, negative a half. So it's going to be a down about there. Then I had 0, 0, which is again at the origin. So I'm hoping that somewhere along the line we're making a connection between why they're all passing through the origin here. Okay. And the last point was 1, and again, it should actually be negative a half because it should go down like so. Okay, so that goes down like so. Right, so what can we conclude? My a value was negative. So this time we can see that my parabola is frowning. All right, so there we go. The a value determines the smiling or the frowning nature of your parabola. What else do we know? The other thing we can see is that because it's a fraction, okay, when you draw your graphs, maybe this is, I hope it's clear, as a fraction, as your a value becomes a smaller and smaller fraction, so your graph becomes wider and wider, okay? And finally, what is the common element here? They all had a q value of 0. And what we should be noticing is that they are all passing through the origin, which is 0. So let's quickly wrap this up in terms of what the a and the q do. The a determines whether your function is smiling or whether it is frowning, and how wide or how narrow the function is going to be. And finally, what does the q do? The q, have I got it here? The q is going to determine what we call the y-intercept. Okay, that's where the graph crosses the y-axis. Okay, right, guys, so that was a bit of an introduction to parabolas. I'm sure we're due for a short break, but when we get back, we're going to practice lots of them.
Right, mindsetters, you've heard it. After the break, we're going to practice a lot more. But I just want to say this shout out to Charlie Tawang and Calvin DeBucks who are joining us. And Pamela, welcome to the show, guys. Check you out after the break. Welcome back, Mindsetters. This is Learn Extra, and today we're doing functions on your mathematics for grade 10s. If you're tuning in for the first time, welcome to the show. Still take your notepad and let's learn more, and your calculator if necessary. But otherwise, you can also chat with me over the page if Temlin is doing something that you don't understand and you'd like to ask some questions. Our Facebook page is facebook.com/Learn Extra. You can also have the notes that we are having for today's show on learnextralive.co.za/live. For now, Temlin, take it away.
Thank you. Right. As promised, let's get going with some examples. Okay, let's put this theory into practice. Let's see how easy this actually is. Okay, we are going to still use a table method, all right, so by means of substituting values of x into the equation to get out values of y. And this is the equation. We've got y is equal to x squared plus 2, all right? Before we even go to the table, let's see if we can already start establishing a few things about our graph before we actually even find y values. What's the value for a over here? If you have a look at it carefully, the value sitting in front of my x that we cannot see, I'm sure by now you're all shouting, is a 1. Okay, it's a positive 1. So therefore, guys, do you agree with me? The first thing I know is my parabola is going to be a smiling parabola. Okay. Right, here's now a slight difference to the examples we did before the break. I now have a q value. In all the previous examples, let's just quickly go back. In all my previous examples, my q value was 0, which meant that all of my parabolas passed through 0, passed through your origin on the y-axis. Now, what's happening over here is that I don't have a 0, I've got a 2. So my q value is 2. So let's see what happens when we substitute our values into the equation. So if I take negative 1 and I substitute it into my equation, which is y equals x squared plus 2, we're going to land up with a y value of 3. If I substitute 0 into my equation, this time I land up with 2 as my y coordinate or my y value. And if I substitute in positive 1, we get our positive 3. So let's plot. Let's see what happens. if I've got -1 and 3, that's going to be my coordinates sitting over here. 0 and 2, now that's over there. That's crossing my axis over there, and 1 and 3 is over here. So we said it was smiling, and it is smiling. It's going to go through here. And it's got my arrows passing here. So what is the fundamental difference between the previous graphs and this one? This graph over here is crossing through your y-axis at +2. All right? So to confirm what we said earlier is that this y value over here, that over there, represents the y-intercept of your graph, of your parabola. And remember, the y-intercept, guys, is just another way of saying where it crosses the y-axis. Okay, so that's the Q. That's what your Q is doing, all right? Now, in fact, it also has another quite interesting effect, or a thing that happens over here with my parabola, and I'm going to explain that to you in a minute, okay? I'm sure you're all looking at it and you already know what it is. All right, so the Q, as we've said over here in standard form, is representing the y-intercept, and that over there, just to explain again, is my y-intercept. All right. What else could that point over there be? All right, something very important that we have to know about a parabola is that it's smiling, okay? And the other thing we always need to know is that it is completely symmetrical. Okay, symmetrical means that if you cut it down the middle, it looks exactly the same on both sides, all right? So it would be completely symmetrical about which line. Now, if we have a look over here, if I were to highlight this line over here, do you guys agree that if I look at my parabola on the left-hand side and on the right-hand side, it is exactly the same? So my parabola is symmetrical about that is your y-axis, okay? And because it's symmetrical, it means that at a particular point, the graph went down and it reached a turning point, and then it went up on the other side. So this over here, the y-intercept, is also, in my parabola, in these equations here, is also going to be the turning point. Okay, and as far as grade 10 goes, okay, we don't ever shift the graph left or right in grade 11. If you're in grade 11, you obviously know this. The graph shifts left or right. Then the axis of symmetry changes, okay? But for grade 10, for our syllabus this year, we're going to work with it that our axis of symmetry is always going to be on your y-axis. So if they ever ask you that question, and I'm quite sure that they will, what is the axis of symmetry of your equation? It's y equals 0. Okay, right, so remember that for me, please. Okie dokes. Axis of symmetry, okay, right. Let's have a look over here. We've got, consider the function f of x, which is equal to x squared minus 9. Okay, guys, just remember bringing up something that we covered last week, our functional notation. Remember f of x, so we're saying that f is a function of x. So when we substitute x's into our equation, out comes the value for y, and the value of y is a function of what we substituted in for x. So therefore, f of x represents your y. Okay. Right, so we've got this equation over here, and the first thing they're asking me to do is to write down the coordinates. Remember, guys, if they ask you for that, make sure you give them the coordinates, which is your bracket with an x and a y coordinate in it, okay? So write down the coordinates of the y-intercept. Right, so this is really important. The second we're looking for a y-intercept, and this doesn't only apply to a parabola, it applies to any function. If you are asked to find a y-intercept, your immediate instinct is going to be to say, let x equal 0, okay? And if we let equal 0, why do we let x equal 0? In fact, let's just establish why we do that. If I'm talking about a parabola, and I'm talking about the x-intercept, I'm talking about that particular point over there. And if we have a look at it, that point over there is on the y-axis, which means that the x-coordinate has to be 0. Okay, so please remember, if you're looking for a y-intercept, let x equal 0. Okay, so let's do that. Let's take our equation and let's work that out. So therefore, I'm going to say f of, now instead of x, we're not the x value we're working with is actually 0, okay? So f of 0 is equal to, and that means that I'm going to substitute my x value with 0, and we're going to work it out. So therefore, what have we got? That's going to give us negative 9, okay? Which in fact we should already know, because we already know that this y, this q value over there represented the y-intercept. So negative 9 is the y-intercept. If we actually go and work it out and we let x equal 0, we still get negative 9 as the y-intercept. What are the coordinates of the y-intercept? So what are the coordinates going to be? My x value is 0, my y value is negative 9. And please make sure you write it exactly like that. Round brackets with a semicolon between the two values. Okay. Right, so that is the coordinates of the y-intercept. Now they're asking us to determine algebraically. So basically what they're saying here, guys, is that we've got no picture. Okay, no one's asking you to do it in terms of a graphical picture. They want us to actually do a sum to work it out. So determine algebraically the coordinates of the x-intercept. Okay, now, x-intercept. For the y-intercept, we had to say let x equal 0. All right? So then what would I have to do in order to work out the x-intercepts? I would have to do the opposite. I would have to let y equal 0. Because where it crosses the x-axis, the y values are actually 0. Okay? So that's what we're going to do. We're going to say let y equal 0. So into my equation, remember f of x represents your y value. So therefore y, no, let's rather make it 0, because we're making it 0, is equal to x squared minus 9. Right, what kind of equation, grade 10s, does that now leave us with? All right, if we look at that carefully, I've got an x squared minus 9. And if we remember our laws on equations, if we've got an x squared in our equation, we have a quadratic equation. And hence, we are drawing a quadratic function, okay? So we've got an x squared minus 9, which means it's a quadratic equation. And what are our rules of quadratic equations? 0 is on the one side, my whole equation is on the other side. So that's done, and we have to factorize my equation. Now that over there, I'm sure we all recognize, is a difference of 2 squares. So that's an x minus 3 and an x plus 3. And if I actually let each of those equations, the x minus 3 and the x plus 3 equal 0, we can then actually solve for x for each of my x-intercepts. So I've got x is equal to 3, or we've got x is equal to negative 3. Now again, guys, watch out. They did say the coordinates of the x-intercepts, which means that this one has got a coordinate of 3 and 0, because that's where the x, if your x is on the x-intercept, your y is 0. And the other one is going to be negative 3 and 0. Okay. Right, so that is now determining the x-intercepts algebraically. All right, and if you've got a quadratic equation, guys, or a quadratic function, you are going to solve it as a quadratic equation. So all of that equation theory does come in here, so don't go and forget that. Okay. Okie dokes, now that we've done that, it's now asking us to sketch the graph of f of x, which is equal to x squared minus 9, on a set of axes. So now we're going to actually sketch this. So first thing we need is an x and a y-axis. Okay, so we're going to call this my x-axis and this my y-axis. And what did we know? We knew that the y-intercept was negative 9. So all the way down on my y-axis, I'm going to plot a point of negative 9. And my two x-intercepts were at negative 3 and positive 3. All right? The other thing we know is that your graph is symmetrical. So remember, it's a mirror image of each other on either side of the y-axis. So therefore, it means that my graph is going to go all the way down through 9, back up again, and it's going to be symmetrical about either side. So where does it pass through the x-intercepts? Let's do a different color. It passes through my x-intercept at negative 3 and positive 3. It's got a y-intercept of negative 9. That value over there, remember, was a positive 1. My a value is positive. So therefore, is my graph smiling? Yep, it's a smiling graph, so we're happy about that. And lastly, we can say that it's got a turning point. It turns at negative 9. And that gives us a special, it becomes quite a special point, because if it turns and it's smiling at -9, that then becomes what we call the minimum value of your graph. Obviously, if it was frowning, the turning point, the point at which it turns around, would be your maximum value. Okay. Okay, so now that we've got this graph, we're going to answer all of these questions. And guys, this is very common with your functions, okay? They give you a graph, or you have to sketch the graph, and then they ask you a whole lot of different questions on your function. So all of these are really important, okay? All right, the first thing they're asking us to determine is then, what is the turning point? Okay, let's go back to our graph over here, and let's determine what were the coordinates of the point at which it turned. Okay, our turning point is our point over here, and that is going to be where x was 0 and where y was -9. So what am I, sorry, wrong way. Our turning point is going to be the coordinates of, I'm going to say turning point is equal to the coordinates where x was 0 and y was -9. Okay, because your graph is symmetrical about your y-axis, the turning point and the y-intercept, guys, are always going to be the same. All right, when we start shifting the graph left and right, then it changes. But as I said, for this year, the y-intercept will correlate. It will be the same as the turning points. Okay. What's the minimum value of the graph? Okay, well, the lowest y value we had over here was at -9. So the minimum value of our graph is going to be y, which is equal to -9. Okay, remember, if it's a frowning graph, it's facing the other way, it won't have a minimum value, it will have a maximum value, which again will correspond with the y-intercept, which is also the turning point. Okay, the domain and range. Right, these are two words that we came up with last week, and I hope you guys remember what they mean. Your domain, remember, are all the values for x that your function covers, from the lowest x value all the way up to your highest x value. Your range, all the y values that your graph covers, from the lowest to the highest y values. So let's have a look at our domain. Now, bearing in mind that I've got arrows on either side here, which means that your graph is not stopping over here and over here. It's not stopping, it's continuing, and as it continues, it will just gradually get wider and wider and wider. So therefore, is there any stopping point as far as how low and how high I'm going to go on my x-axis? Well, no, okay, there isn't. This graph is gradually going to get wider and wider and wider as we continue on our values. So therefore, what is the domain? The domain is going to be this. We're going to say domain is going to be from -infinity all the way to +infinity. There is no stopping my x values over there. Okay. The y values, let's have a look. The y values may be a different story. There is a minimum y value over here. Bear in mind that your graph turned at the point of -9. And because it's turning there, it obviously is not going to go any lower than that. So because we have to go from the lowest to the highest y values, my lowest y value is going to be down at -9. All right? Are we actually including that point of -9? Yes, we are. And where is it going to go up? Because of the arrows, again, it's going to just carry on going and going and going to infinity. So what have we got in terms of the range? Right, the range is going to be, because we are including the turning point, we use a square bracket from -9, and it goes all the way to infinity, which, remember, is a round bracket because we can't include the value of infinity. Right, guys, I'm going to continue with this question, but I think we all need a short break.
I have a quick question based on the second question that you have there about the turning point. There's Chamberlain saying, I really don't understand what do you mean by the term turning point?
Turning points. Okay, well, let's have a look over here. If I were to redraw this graph, can we say it's decreasing and it's decreasing and it's decreasing all the way down, and as we go, it's continuing to decrease. Now, as I hit that point over there, it's going to stop decreasing, and as we now go on the other side, it is now increasing. It's going to go up, 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 and so on. So this point over here, which I've referred to as the turning point, is a point where it's gone down. If you were to think about it as throwing a ball in the air, all right? If I were to throw a ball in the air, we're going to throw it up, and it's going to go up, 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 and it's actually going to reach a point where it stops in the air, and then it's going to come down again, all right? So that point at which it stops is its turning point, okay? It's at its maximum height, and then it's going to come back down again. So that's what your turning point is referring to.
Simplified. Let's learn more after the break. Mindsetters, do stay tuned. See you after the break. Welcome back, Mindsetters. We're still learning a lot, and you can tell the energy is just supercharged. But now, unfortunately, you know, they say time always flies. It's that time where we need to rush through, and I hope you're learning. If you're not understanding anything, make sure that you chat with me over the page, facebook.com/learn extra. We'll be here to learn with you and also help you through. But this time, Tamlin, take your time.
Right, let's carry on with the question. Okay, we weren't quite done over here. The next question that typically we will ask you with regards to this graph interpretation is the equation of the axis of symmetry, right? Axis of symmetry, let's just highlight it in a completely different color over here. There's your axis of symmetry, guys, which is your y-axis. What is the equation of this line? At this point over here, your x value is 0. So the equation of this line over here is going to be x equals 0. And that's your answer if they ask you for the equation of your axis of symmetry, x equals 0. Okay. Right, another typical question. The values of x for which f is increasing. Okay, you think about what they're asking for here. They want the values of x. So we're looking on our horizontal axis for which the y values are increasing. So let's have a look at our graph. We're looking on our x-axis, so we're going horizontally across my x-axis in that fashion over there. Okay, so as we do this, we are going to be looking at what the y values are doing. Are they increasing or are they decreasing as my values for x are moving along? Now, as we go along the x-axis in a horizontal direction, we should notice that this y value, all these y values are getting lower and lower and lower and lower up to the point at which it turns. And from this point over here, it will then start increasing, in which case it will start getting higher and higher and higher. So for which values of x are my y values increasing? It was basically everything from 0 to infinity on my x-axis where my graph was increasing. So therefore, I'm going to say that x is going to be an element from 0 to infinity. That's where they were increasing. Where were they decreasing? They were all the values on our negative x-axis that they were decreasing. There we go. Those were the decreasing y values. So what are my values for x for which my graph is decreasing? X is an element from negative infinity, guys, always from lowest to highest. And going to be, in fact, I'm going to actually correct myself here, guys. I've done a square bracket. I've done a square bracket around 0, but in fact it shouldn't be. It should be a round bracket over there and over there. Why? Because if we look at the graph, at this point over here, at a turning point, let's go back to our scenario of a ball. If I threw a ball up in the air, the point at which the ball actually turns around, it's not going any higher, and at that fraction of a moment, it's not getting any lower either. It's standing still, okay? So in fact, it's neither increasing nor decreasing, so we're not going to include that point, okay? So therefore, 0 is actually a not included value in each case over there. Finally, write down the equation of the graph formed if f of x, which is x squared minus 9, is shifted 10 units upwards. Right, let's take our picture. So what is happening is that this graph is going to be moving 10 units up. Now, what's changing essentially is that this graph will then look like so. It would move all the way up to there, which means what would the y-intercept then become? If it went all the way from -9 up 10 units, it would go to +1, okay? So what would the equation of our graph be? It would be f of x is equal to x squared, and my new y-intercept would be positive 1. Okay. Right, guys, moving along, we've got no time to lose. Let's have a look at what we would do if we've got a parabola and they've asked me to find the equation of the graph. Back in our key concepts, I mentioned an equation that looks like this. We've got y, which is equal to a multiplied by x minus x1 multiplied by x minus x2. Okay? The x1 represents your first x-intercept, and the second represents your second x-intercept. So in order to find the equation of this parabola, what I'm going to do is substitute my negative 4 into my x1 and my positive 4 into my x2. Okay? So therefore, this is what we will then have. I've got y, which is equal to a, x. Now, if I substitute negative 4, that means I've got two negatives, which is going to become positive, and x minus 4 over there. Okay, that's all fine, but I still have too many variables. It's a problem. We need to get rid of some variables here. And what we're going to notice is that I've got a coordinate point over there. I've got the point of negative 1 and 15. And remember with the graph, the best thing about graphs is that if in doubt, if you've got a point that is sitting on your line, guys, you are always allowed to sub it in. Okay, so x is negative 1, y is 15, and that's exactly what I'm going to do. I'm substituting everywhere I see an x with a negative 1, and everywhere I see a y, and everywhere I see a y with a 15. Okay, so that's what we've got over there. And that's leaving me with just one variable to solve for, which is my a. So therefore, I've got a 5, I have got, no, so that should be 3. Hey? Okay, let's just make sure we get those right. Okay, so we should have 3, and we should have negative 5, which is going to give us negative 15, which if I divide positive 15 by negative 15, we get negative 1. Guys, looking at your graph, should the a be a negative? Okay, should we confirm that? Let's have a look. Absolutely, it's a frowning graph. So yes, it should be negative. So what have we got in terms of our equation? I've got y is equal to, instead of a, I've got a negative 1, and I've got an x minus 4, and I've got an x plus 4, which we're now going to just multiply out, okay? That's going to give us x squared minus 16, and if I distribute my negative, I'm going to land up with negative x squared plus 16, and what is that plus 16 again? Let's go back to our graph. That would represent the y-intercept, or the turning point, or the maximum value of your graph. So it's got lots of different characteristics at one little point over there. Okay, right. That's the parabola. Okay, you guys need to go and practice it, go and draw lots of them, go and practice finding the equation of them. They are very important graphs to understand. Okay, right, guys, let's have a quick look at exponential functions. Yes.
Before you move on to that, I have two questions based on the domain. The first one is from Bradley saying, can you please explain again what you mean by the domain? But another specific one is from Gumani. It says, when writing the domain, is it okay if I write x is an element of a real number?
Absolutely. In fact, that's a very good question. Instead of writing from negative to positive infinity, another way of writing it, it means, and neither one is correct or incorrect, it's just another way of writing it, is to say x is an element of any real number, which it is, because you're covering everything from negative to positive infinity. Regarding the domain and range, I'm going to suggest something. On our notes from last week, which I think are still on the website, go and have a look at those notes regarding domain and range. We covered it quite extensively there, and just go have a look at it, but I'll try and incorporate it into the exponential graphs just so we can help you understand that as well. Okay, so we can kill two birds with one stone there.
Yes, I'll make sure that I post the
Perfect,
the notes.
That's great, super. Okay, the exponential function, let's just quickly look at our standard equation. Y equals ab to the power of x plus q. Okay, what we need to understand about our exponential graph, all right, is that this over here is our standard shape. That's what our standard exponential graph is going to look like, okay? The a, what does the a do in our graph? This a determines whether your function is a positive or a negative function. If it's positive, your function will always be on the positive side, on the positive y-axis. So it's always going to be on the upper half of your Cartesian plane. If your a is negative, it is always going to be on the lower half of your Cartesian plane. So that's what you need to always be aware of with regards to your a value. And your q value is going to determine the y asymptote. Okay, remember we said the asymptote is a line that your graph gets closer and closer to, but it never actually touches it, it never crosses it, okay? So if my y in asymptote is greater than 0, we can all see this dotted line over here. This over here represents the asymptote. And my exponential graph will get close to it, but it never ever crosses. Whereas if my y asymptote was less than 0, so in other words it's lower than 0, so it would be below the x-axis, but again you can see that the the exponential graph will never ever cross it. Okay, so watch out for your asymptote. It's a really important part of your exponential graph. It determines how high the domain, well not the domain actually, it determines the range of your exponential graph. It really does. Okay, so let's have a look at an example quickly and let's see if we can just quickly draw this so you guys are all happy and understanding. Right, what have we got here? I've got a 2 to the power of x minus 2, okay? The first thing I think is important to note is always note what your asymptote is and draw that onto your axes, okay? Just sketch that in because you know that that's a really important part of your graph. So I'm going to take a dotted line, let's just use a green one, and I'm going to do a dotted line through the point of y equals negative 2. Always make sure that you label your asymptote. Okay, so give the line an equation, and this one is y equals negative 2. All right. Now we need to plot the graph. Your best bet, guys, is to do it by means of a table. Okay, so give yourself a table with x values and y values, and you can substitute in. The other option, remember last week I showed you how to plot it with a calculator, and let me show you again. We press mode and we press 3 for table. That brings up our equation, which we are going to type in. No, we want it as an exponent. Minus 2. It asks us where we want to start. I'm going to tell it at -5 and to end at -5, going up in steps of 1. Right, and it gives us all the points that we need to plot, the x and the y coordinates all the way along it, okay? Right, I'm not going to spend too much time plotting it too accurately purely because of time constraints, so I'm going to just draw the graph, okay? The one point, in fact, that I am interested in is what is the x-intercept, and the x-intercept is going to be where the y is equal to 0. Do we have a y equals 0 here? Okay, let's see. Okay, all right, let's find points that we can plot here. Where x is 1, y is 0.5. Where x is 1, y is 0.5. That's a point we can plot. Let's see what we've got here. Where x is 1, 2, y is 1. Okay. All right, so sorry guys, because of time, I'm not going to be able to plot this too carefully, but let's just give you an idea. So essentially your graph is going to go like this. It's going to go through here, it's going to pass through your x-axis at a particular point, it's going to get closer and closer to the asymptote, but it will never cross it, and in fact it takes a more regular, it has a more regular curve than what my picture actually looks like over there. So what's important when you're sketching your exponential graphs, make sure if you've got a positive value as the coefficient of the first term is positive, the graph is on the upper half of your asymptote. The asymptote itself, make sure that that's always a dotted line passing through your y-axis. Label your asymptote. That's a really important mark that I don't want you to lose in your plotting of your graphs. And then make sure that you've plotted, when you're plotting it, guys, you don't need to be ultra specific about it because it does get very, very small. It gets ridiculously small. So the point is you're wanting a relatively close representation of your graph. Draw a few points, plot a few points, but you don't need to be too serious about the 0.00067 value, okay? Those you don't have to worry about too much. Use your calculator. Practice that method of actually plotting points on your calculator. It is extremely handy. And that same method can be used for your hyperbola as well as the parabola and the straight line graph. So you've got to now actually establish a method or means of sketching these graphs that works for you. You have a few methods available to you, and as long as you are correctly labeling your graphs, correctly filling in coordinate points such as x and y intercepts and turning points and so on, as long as you are filling in all of that essential information on your graph, you will get the marks that you need. Okay. Guys, I hope that that gives you a good introduction to your functions and that everyone's
One last question,
understanding.
Timlin, from Timosho quickly. It says, I don't understand with determine increasing and decreasing x values.
The x values, once again, I can give you a very quick, let me try this on the graph over here. I'm going to black it out for a second and I'm going to pull it across. Okay, look what I'm doing over here. I'm pulling the shade of the screen horizontally along the screen like so, okay? And that's what you're doing. You're going horizontally across the screen. And as you're doing it, look what's happening to the purple line. It's getting higher and it's getting higher and it's getting higher as I'm going along my x values, okay? So for which values of x would this graph be increasing? Well, it's going to be all the values for x. As I go along, the whole way along my graph was increasing. So to answer that question, using this as an example, the values for x for which your graph would be increasing is that it would be an element of any real number because your graph increases all the way along. And that's what you need to do, guys. You need to look horizontally across your x-axis.
Thank you very much, Timlin.
Pleasure.
Otherwise, Mindsetters, thank you for the great time. Thank you for tuning in. Great hands. Hope to see you next week again, learning more right here on Learn Extra. From me, Abraham, and Timlin, for now, we just want to say goodbye. Check you out some other time.